Hello there, and welcome to the first lightning talk of our Maker series on computer science fundamentals. I'm going to be talking about algorithms, specifically sorting algorithms, and overlaying the basics of what they are and how they work. So what is a sorting algorithm? For that, I'm going to open up Safari and I'm going to go onto Wikipedia. So I'm typing in wiki algorithms, and we're going to click on the first result that comes up. Just Wikipedia. So according to Wikipedia, in mathematics and computer science, an algorithm is a finite sequence of... Let's go to the jargon-free version. That'll be better. Right, so an algorithm is a self-contained step-by-step set of operations to be performed. And this is the important part, the step-by-step set of operations. So essentially it's a sequence of steps that have to happen for you to get a result. And to demonstrate that, we're going to go on to our first algorithm. A good cup of tea. Every time you make one, you're following an algorithm. So, what do you need to make a cup of tea? Well, you need water, tea, obviously, some kind of vessel to boil the water in, and then you need a bit of time for everything to brew. Well, making a cup of tea has a few steps. To start with, let's put some water in a kettle. On a flow diagram, you can represent that like this. Once the water is in the kettle, we can put the kettle on boil. Let's represent that like this. What's the most important part of this diagram? The little arrow between these steps. This arrow represents sequence. Only because of this is the boil able to run. Step 2 is dependent on step 1. Let's leave that aside and continue making our tea. I now need boiling water, so I guess I should check if my water is boiled. If the kettle is boiled, I want to move on by adding the water to the mug. You could represent that like this. What I've got here is selection. There are 2 rows I can go down. If the condition is true, go down one path, otherwise go down the other. Let's consider the other path. If the water is not boiled, I want to wait for a few seconds and then try again and again and again. This is called iteration. I want to do something again and again until a condition is met. Now I bet you actually know how to make a cup of tea, so I'm going to jump ahead to the end of the tea diagram, but have a look at it and let it sink in. Every time you've made a cup of tea, you've been following the algorithm. And on the right hand side is a mock Java code representation of that. I'm going to demonstrate selection sort just so you know the difference between insertion sort and selection sort. So let's shuffle this up. Cool. So you start at the beginning and you look for the smallest number in the set. So we start at 8. Right now 7 is the smallest. Then 3 is the smallest, so we go and we select that. 2 is smaller than 3. 1 is smaller than 1, and then 2. 1 is smaller than 4, 1 is smaller than 6, 1 is smaller than 5. And you take these numbers and you swap them around. Next, you don't start from the beginning again, you start from the next number in, because you know this is already the smallest one. So 7. 3 is smaller than 7, so that's the smallest right now. 2 is smaller than 3. 8. The 2 is smaller than 8. 2 is smaller than 4, 2 is smaller than 6, 2 is smaller than 5. So we take the second number, we swap them around. On to the next one, and we'll look for the smallest number, smaller than 3. So 3 smaller than 7, 3 smaller than 8, 3 smaller than 4, 5. So that must be the smallest one because that's the smallest in the set. Next. So it's smaller than 7. It's definitely smaller than 8. So 4 is the smaller number. And 4 and 6, 4 and 5. 4 is the smallest. 8. 7 is smaller than 8. 6 is smaller than 7, 5 is smaller than 6. So that gets swapped over with 8. Next, 7. 6 is smaller than 7, 8 is smaller, 6 is smaller than 8. So 6 gets swapped to 7. So 7 is definitely smaller than 8, so it stays where it is, and then 8 is the last. And that's how selection sort works. So insertion sort works very similar to selection sort, where selection sort took the numbers and they swapped them around. Insertion sort inserts that number into where it's supposed to be. So let's demonstrate it. So let's randomize this sequence up. Let's go. So as always, you start on the left-hand side, and our number is 3. It can't compare itself to any other number, so it's the highest and the smallest number at the same time. So we'll go on to the next number in the sequence. 2 and 3. 2 is smaller than 3, so it inserts itself into the smallest position and 3 into the highest. This is pretty much it. So next is 4. 4 compared to 3 is 4 is bigger than 3, so it stays where it is. As it's bigger than 3, it knows it's going to be bigger than 2. So we'll go to the next one. 1 and 4. Comparing 1 and 4, 1 is smaller, so that gets inserted into there. 1 and 3, 1 is smaller than 3, so it gets inserted into there. 1 and 2, 1 is smaller than 2, so it gets inserted. And that's our sequence of numbers. So it doesn't have anything else to compare itself to, so it must be the smallest number. So we're going to the next one. 8. 8 and 4. 8 is bigger, so we know 8 is going to be bigger than any other of these numbers, so it stays where it is. So we go on to the next one. 5 and 8. 5 is smaller than 8, so it gets inserted into that position. 5 and 4. 5 is bigger, so we know it's going to be bigger than any one of these. So on to the next sequence. 7 and 8. 7 is smaller, so it gets inserted into that position. 7 is bigger than 5, so it stays there. And 6 and 8. 6 is smaller than 8, so that it gets inserted into there. 6 is smaller than 7. 7 and 5. Or 6 and 5. 6 is bigger than 5, so it's going to be bigger than all of those. And then, because there's nothing else to go through, this is our sorted set of numbers. Right, so I'm doing merge sort. Merge sort uses the divide and conquer strategy, which means it takes a number, breaks it down into smaller pieces, and then it gets merged together to solve it, pretty much. It's much easier to understand it if you see how it works. It's easier to get a handle on it. So we have our numbers here. I'm going to randomize it quickly. Cool. So that's all showing. Go. So we're first going to break it up into smaller pieces. So we're going to halve this number. So we have 2 sets of 4. Then that's going to get halved again. So we're going to halve these into 2s. 2, 2, and then 2. And then that's going to get halved again into the smallest pair. So it'll be 1, 1, 1, 1, 1, 1, 1, 1, 1. Now we have 8 sets of 1s. This is where the comparison starts. Well, this is where the merging together starts. So we always start on the least side, which will be the left side, pretty much. And then we start comparing them, and then we start merging them back together again. So we compare 3 and 4. 3 is smaller than 4, so it goes down as it is. 7 and 2. 2 is smaller than 7, so it goes down first, and then 7 afterwards. We're comparing 5 and 8. 5 is smaller, so it goes down first. 8 after that. Comparing 1 and 6. 1 is smaller, so we're going down first, and then it's 6. then we're going to compare the pairs. We always compare the first of the group, so the smallest ones. Comparing 3 and 2. 2 is smaller, so we're putting that back in first. Comparing 3 and 7. 3 is smaller, so I'm going to put that next in line. Compare 4 and 7. 4 is smaller, and then we have 7. On to the next group. Right, so we're going to always start on the smallest one. So 5 and 1. 1 is smaller than 5, so we're going to put that down first. Then we compare 5 and 6. 5 is smaller. 8 and 6. 6 is smaller. 8 is the last one. And then this is our 2 pairs of 4s. If you'll notice, they're already pretty much sorted. Now we just need to sort of merge them back together again. So we start off on the smallest one. 2 and 1. 1 is smaller. 2 and 5. 2 is smaller. 3 and 5. 3 is smaller. 4 and 5. 4 is smaller. 5 and 7. 5 is smaller. 6 and 7. 6 is smaller. 7 and 8. 7 is smaller. And then 8 is the largest number in the group. And that's merge sort. It's pretty simple, really. Now these are the only algorithms I'm going to talk about because they were the ones that I was quizzed on in interviews post Makers. Merge sort is still actively used in big data, and if you can get a good grasp of how it works, it'll definitely help in data interview situations. I would actually really encourage you to get some post-it notes or cards, playing cards, and try to recreate all the algorithms using those, and once you're happy with how they work, go ahead and try to code it. It's really the only way to properly understand them. Now, sorting algorithms are dictated by something called the Big O notion, which I'm not going to go into because it really needs its own lightning talk. It pretty much describes the complexity of your code using algebraic terms. And what that means is not all algorithms are one size fits all. Insertion sort is great for streaming data, but really not great for anything else. Whereas merge sort is great for large data sets, not for smaller sets or being used on older computers because of memory limitations. And that's it. Thank you very much.